Welcome. This is our Algebra 2 Quadratic Functions Lesson 7 Quadratic Inequalities in One Variable Overview Part 1. If you have any questions about the material that's after the video, please leave questions or comments in the comment section below. And if you find this video helpful, please give a like and subscribe to the channel if you've not done so already. Watch our other videos on the Quadratic Functions series. Question number 1. Which of the following values of x is solution set of the inequality x squared plus x minus 2 is greater than 0? Hint, to make it easier, generate a table on your calculator using y equals x squared plus x minus 2. Well, we could do that, and that's fine. One of the things we can do also is plug in. That's one way if you don't have a calculator, though. But we are going to go with the suggestion that they give us. So let's bring up our calculator. So we're going to type in y equals x squared plus x minus 2 in our calculator. Let's bring up a calculator. So we go to y equals, type in x squared plus x, I believe it was minus 2. Okay. And what we're going to do is hit second table to take a look here. And ooh, wow, let's reset our table here from before, I think. So okay, so I'm going to change it to auto. Okay, sorry about that, everybody. It's from a previous problem. Okay, and so hit second table, and we're looking at values greater than 0. So let's take a look back at our here. We said it says which of the following is values of x in the solution set. So we're looking for values of x that will make this inequality greater than 0. So we have 0, and so we start -2, 1, 0, -4. So let's take a look. Let's go back to -2. Go to -2. That's a 0, which is not greater than 0, so no. Okay, 0, x equals 0, that gives us a -2, so that means no, that's not greater than 0. Greater than 0 means positive, and 0 itself is not a positive number. So when x equals 1, that's 0 as well too. Now when x equals, I believe the other one was -4. Let's take a look at -4. Now -4, oddly enough, here gives the value of 10. And so at this point, if we plug in -4 into our function, we should get a positive value. Let's go back and check. So we can double check here and do y is equal to, y equals -4 squared plus -4 minus 2. Well, not equals to. Let's really check out and see in this case. Does this end up being greater than 0? So we have 16 plus -4 minus 2. That gives us 12 minus 2. It gives us the value of 10, which is greater than 0. So -4 is the correct answer for this question. Okay. Number 2. Which of the following values of x is non-solution set of the inequality 5x squared plus 35x is less than or equal to 0? We can plug in numbers, and we'll see how it works out. So we plug in -1, so 5 times -1 squared plus 35 times -1. Is that less than or equal to 0? Well, this becomes 5, because -1 squared is 1 times 5 is 5. But 35 times -1 is -35. And that's equal to -30, which is definitely less than or equal to 0. So the key thing is not, though, so it can't be this one. All right, let's plug in 2. 5 times 2 squared plus 35 times 2 less than or equal to 0. Okay, what we get in this situation, we get 2 squared is 4 times 5 is 20. Plus 35 times 2 is 70. Hey, this is 90. 90 is not less than or equal to 0, so it can't be this one. Okay, so looks like choice 2. If we plug in 0, just to make sure, if you plug in 0, 5 times 0 squared plus 35 times 0, that's equal to 0, and that's less than or equal to 0, so that works out. So. And I will double check the last one, -7, just in case, people go, well, how that doesn't work and all. So we have 5 times -7 squared plus 35 times -7. And so what's that equal to? Well, we have in this case, oddly enough, the negative 7 times 5 is going to be 49. So negative 7 squared is 49 times 5. 49 times 5 is equal to 245. And then 35 times negative 7 is equal to 210 plus 35 is, 245 as well. So negative 245. And that's equal to 0, which means 0 is less than or equal to 0. So yeah, just to make sure that they'll work out in this case. Okay. So number 2 is choice 2. That one's not part of the solution set though. Oddly enough, all the other ones worked out, as far as, working out to get 0. So isn't that kind of nice? Well, I mean, not 1. Negative 1 was definitely negative 30. It was less than 0. So the solution set of the inequality x squared plus x squared is greater than 25 is which the following. Okay, so for this one, we definitely need to be able to take a look at some of the rules in this case of solving inequalities, and of course this integral, the way they have this interval notation. Okay. There's a method we use called sign analysis, and so let's go over the steps in this case. So this method we use to solve quadratic inequalities, is called sign analysis. Our first step, find the important numbers of quadratic by factoring in this case, find the roots of the quadratic equation. Step 2, put the numbers on a number line to create regions. Step 3, pick a number in a region and plug that into the factored quadratic expression, determine if the sign value is a positive or negative. Step 4, repeat for the other regions. And step 5, determine which regions satisfy the inequality. Now I know in this case these steps kind of like don't make sense until we actually try this out. So let's go back to question number 3 and we'll see if this works out. Okay. All right, so we want to set this equal to 0, one side equal to 0. Okay, so we're going to take our x squared greater than 25 and subtract 25 on both sides. So we have x squared minus 25 is going to be greater than 0. We're going to factor here the x squared minus 25 and get x plus 5 times x minus 5. These are what quadratic pairs in this case. Now, the roots in this case, so the values of x that make the expression equal 0 would be, well, x plus 5 equals 0 and x minus 5 equals 0. If we subtract 5 on both sides, we get x equals negative 5. Add 5 on both sides, we get x equals 5. So we found our roots, okay, just like you solve any quadratic equation. Now, for the number line we're talking about here, our numbers are negative 5 and 5. Now, I do not need to post any other numbers on this because what happens is these numbers create a region, 3 regions for us to kind of investigate the sign values. And I'll call this section here for all values of x less than negative 5, region 1. I'll call this section here where all values of x are between negative 5 and 5, region 2. And finally, for all values of x greater than 5, region 3. Now, what do we do here? Well, we're going to plug in values of x into, just pick a value in that particular region, plug it back into our quadratic expression, and see if what sign value we get, okay? It's kind of like guess and check, but in this case, when the quadratic expressions get more complicated, this method, is going to help us out tremendously. So the idea is that we're factoring everything. So first, in region 1, let us pick a value for x, where x is less than negative 5, and it means we're going to the left. So for example, we can pick a number like x equals negative 6. On the number line, negative 6 is the left of negative 5. So we'll plug now that into our expressions here, the x plus 5 times x minus 5, and see what we get. We don't really care about the numerical value, just a sign value. So we see here, we can plug in negative 6 for x, so negative 6 plus 5 times negative 6 minus 5. And here, negative 6 plus 5 is a negative number, and negative 6 minus 5 is a negative number. And if you multiply a negative times negative, you're going to get a positive result. So if we plug in any value of x less than -5 into our expression of x squared minus 25, we're going to get a positive value. Okay, let's check out region 2. Now we'll pick a number between -5 for x, pick a number between -5 and 5. And I like picking a nice round number of 0, because calculation of 0, really nice and easy. So I plug in 0 for x. So 0 plus 5 times 0 minus 5. Now again, you're saying, why are we doing that, Mr. Gunn? Why would you plug into x plus 5 to x minus 5? Well, it's a lot easier that, when we have factors, just to figure out signs. We don't really care about the numerical part of it, just the sign value. Because in this case, this number x equals 0 only represents a sample in that entire region. And we know what's true for that region will be true for any value of x in that region for the inequality. So we have 0 plus 5 is positive, 0 minus 5 is negative, and a positive times a negative is going to be a negative value. So we get a negative result. For any value that actually plug into the inequality, we get a negative value. Finally, for the third region, let x equal to greater than 5, I'll pick 7. Right? And so we plug in here, and we're going to get, in this case, 7 plus 5 times 7 minus 5. We get a positive result, and also 7 minus 5 is a positive result. A positive times a positive will give you a positive number. Okay? So now we've found our sign values for the entire number line. And now we want to solve, in this case, greater than 0. Now, greater than 0 is going to be positive. So that would mean, in this case, that we're looking for a solution that's going to be open circle at -5, and here, less than 5, because that's a positive section. And an open circle at 5, and because we're positive, we're going for greater than 5. So normally we write this down as x is going to be less than -5, or x is greater than 5. And then we have these things called this interval things here. And what happens in this case, you might have learned previous lessons, Algebra 1, it represents, in this case, the idea of a parenthesis represents kind of like an interval. So, for example, this here for number 1 would mean all values of 5, or for all values of 5, not including 5, greater than 5, and go to infinity. Okay, so this actually looks like, this represents x is greater than 5. The brackets mean we're including the values, and so that would look like it would be from -5 inclusive of x, including 5. And honestly, those two not working out because they're not enough here. For number 4, this would be for all values of x less than or equal to -5, which we don't have that in this case. Instead, what we have here, this here represents x is less than -5, because negative infinity means going on forever to the left side. Okay? And on the right side, we have here 5 and 2 positive infinity, which is x is greater than 5. And this symbol here means or. So this one would be choice number 3 is exactly what we want. Okay? All right. Okay, ladies and gentlemen, this is going to be the end of our Algebra 2 quadratic functions, lesson number 7, quadratic inequalities in one variable, home review part 1. Okay, if you found this video helpful, please give a like and look out for our next videos. Look forward to seeing you in them. Take care, everybody. Be safe.